Well, hello and good morning, and thank you for joining me in my shop here. It's March 18th, the day after I discovered this speaker doesn't work. So today's video is going to be about the speaker and about alternate speakers, just to show you what I've got here. I dug out yesterday. I got two more field coil speakers here. They're both very large. They're much bigger than physically bigger than this one. I think this is probably 10 inch, so those are 12. But they have a field coil and they have an output transformer right on them, so there's a good chance I could just swap it out. Never done this before, so my first approach, I think, is to try to fix this speaker. I started at that yesterday, right at the end of the video, then I stopped when I discovered that there's an asbestos tape over top of this, which is still here. You can see the asbestos there. And I didn't want to tear it apart here in my shop, because as much as I don't think I would be at risk from the fibers, I just assume not. If I don't do it in my shop, then I'm not at risk in here. I don't want to fill my shop with, invisible cancer-causing fibers floating around. So, what to do about the speaker? Really very convincing test that the coil is shot. I just don't think there's any question about that. Now, what happens? What could happen to a coil like this? What is it? It's just a bunch of wire. It's a continuous piece of wire going around and around. It's insulated. It's either the wire's been coated with varnish, which is quite possible, or something else. One of the ways these speakers can go defective is the winds develop a short. So you have a winding, this is the wire coming around, and two windings make contact and short out. Now, the fact is, a couple of windings wouldn't matter actually. You wouldn't even know it. You wouldn't know it in a transformer, you wouldn't know it here. If a couple of windings short out, you've just changed the winding ratio in it a little bit, or changed the impedance of or the inductance of the coil, or whatever. And that does happen. I'm sure that happens, and it happens in a case where when the two wires short, it's obvious something has gone wrong. They can short in such a way that there's almost no windings left, and then the coil becomes like a short circuit. So transformers can cook really quick and the like. Is that what happened here? No. There's not looking at a short between windings, because that wouldn't have caused this to go open, the input to go open. The other thing that's in there, along with this endless bundle of wire, is there must be two connections for the two wires coming in. Often these coils, especially transformers, output transformers, the wire that's hanging out of them is the actual wire that they're wound with, and you can tell because it's usually coated wire. It doesn't have it doesn't have like plastic insulation on it. It's just got varnish on it or something like that. That's not the case here. These are, covered wires. So in here there must be a connection, because these wires are not what's wound around inside here. No way. So where's the connection? It's probably right here. It's probably right here behind this tape. And so cutting this away and looking is a good idea. Another idea would be, and this is on the idea of trying to investigate the failure in here, would be to put a high voltage on here, maybe 200-300 volts, and see if we can't get the fault to arc and spark inside. That would indicate, a separation is the problem. I mean, there must be a separation. There's no current going through it, and there must be a separation. I did hear some snapping when I turned the radio on. It was more like ticking. I wouldn't say snapping. It's like tick, tick, just a couple of little ticks. That could have been electricity jumping the gap in here. I don't know. We're only guessing, but sometimes you got to start with a bunch of guesses and try to come up with some logical way forward. So, should we try the high voltage thing? I don't exactly have the best equipment for doing it. I can dial up about 300 volts, 400 volts. To jump a gap, virtually any size gap, you need about 600 volts of pressure to jump almost any gap. Incidentally, that's why an awful lot of electric systems they have a 600 volt level, and then above that the rules change dramatically. Above that, 600 volts kind of seen as a change over from won't jump a gap to you could get an arc between over a gap, something like that. I'm kind of making that up, but that seems to make sense to me. I think the name of the game is get this asbestos tape off of here, examine what's going on. If we see something, and what could be going on, what would make a connection fail? Well, first of all, the connection may be a soldered connection, and it may, over time, the solder is a soft metal, a soft alloy. It's active. It's moving inside it. It's not rigid, completely rigid. Well, all metals are kind of like that. And so over time, things can happen to the metal, and it can develop a crack, and then your splice can open up. And it would open up initially just the tiniest amount. The first failure would be the tiniest gap you could imagine, and that's when you might get 600 volts jumping it, or even less. Really, wouldn't you think so? Really tiny gap. That's quite likely what has happened. The splice, however it was made in here, has failed, and if that's the case, I can probably get at it and probably fix it. So I'm going to take this out of my garage. I'm going to peel that stuff off of there and then bring it back in after drinking coffee too. I'll do two things. Okay, so I went out in the garage and I peeled off the outer layer of tape, and you can see the wire here and the other wire here. When you get a closer look at it, there's some kind of connection sticking out here. Let's take a closer look. I think I probably have to dig deeper in there. Let's find out. Okay. So this is a little odd. What is this doing out here? Look at the wires. It looks like probably these wires were actually bent upwards, and then this layer of tape applied, and then the wires were bent downwards over top of this tape. And the actual wire connections here are hidden under this other tape I haven't peeled off yet. What is this thing sticking out here? Really, what is that? I mean, it looks like a splice. It certainly looks like a splice. Paper is pretty shot. Now, if I look like I'm having trouble moving the screwdrivers, because I'm watching this on the TV screen just like you. I'm not looking right at it. Now I'm looking at it. What is that? What is this? I think it'd be part of the splice, that maybe they made the splice and then they pushed the wire over this way, and this other one they've made and they've pushed the wire up that way. Keep these wires separate. We got to go into this tape too here. All just paper tape. Oh, Jim, don't catch a wire like that. say I understand what's going on here. Well, there is a hum coil. There's a hum coil in here somewhere. This maybe so the hum coil wires go in here, the other side. And my guess is they're attached under the same tape the same way. And what is the hum coil? The hum coil is a separate turns of wire up against this coil to pick up a little bit of the hum and deliver it to the voice coil in such a way as it bucks any other hum that might be coming in there. Am I breaking wires here? Of course, I didn't really say it, but the wires inside these things are fairly fragile. Can't be too small, because these ones got to carry 20-30 milliamps, something like that. Hold still. Probably what we should be doing now. Oh, you know what I should have done? Not the end of the world. I should have had the voltmeter connected, or ohm meter connected the whole time I was doing that, and keep an eye on any suddenness. Whoa! I almost forgot. There's two big speakers on the floor right behind me. Stick my foot through one of them if I'm not careful. So while I'm poking around, the connection may be coming and going, and that would be a good thing to be aware of. 600,000 scale. No luck so far. Let's just wheel this around a bit. Nothing happening. What are the chances I'm on the wrong wires? What are the chances? I tried to make sure it's absolutely not the chance. No, there's no way. I got the right wires here. Check my clip leads. Yeah. Well, it would have been nice if we saw some fluctuating already. But so, as it looks more and more like the speaker is never going to work, I get more and more aggressive with attempting to fix it all the way along, realizing what I'm doing can be destructive. These feel really loose here now. How did that happen? Because, unless this is sorted out, the speaker's not going to work again. Oh, here we go. Okay, I can now see. In fact, this wire it's connected. There's a very fine wire under there. Fixing these connections is not easy either, but it can certainly be done. I'm just going on the assumption that it's right here. Come on out of there. And the other thing is, I could very well break the wire while I'm doing this and then think, aha, I found it. But actually I did it. Let's take a look at that before I poke too much further. Okay, take a look. What do we got here? So on this connection, you can now see the wire coming out of the coil. It's this very, very thin one you can see in front of my finger. You can see what they've done. They wrapped it to the end of the wire and soldered it. That's really very, very secure. So, not this connection. Well, what about this other one? Wire look a little green. It might have a bit of a green patina on it, which would be a suggestion that moisture has gotten in here. Where's the wire? Where's the wire that comes out of the coil? Oh, it's right up at the top here, I think. camera's bouncing with my heartbeat. My heart is actually pounding while I'm doing it. Funny, eh? Okay, let's try to steady the camera as much as I can. Let me get it aimed right here. Oh, okay, so this is the one we sorted out. This is the other one. Where's the connection? There's no connection. There's no wire. Well, I think we found the problem. So, really, I didn't even say this, but I was a corrosion technician, by the way. Really, the only way for a connection like this one, to fail, this one over here, is for it to corrode. And the wire itself could break. And that looks like that's what's happened here. You can see some green, that'd be the corroded copper. And where's the wire? The wire's going to be back here somewhere. If I can find it and get a tug on it, I might be able to pull it out. They're probably looking right at it there. I'll put it right in the center. Do you see a little bit of copper? Yeah, okay, that's good. I'm going to stop now because we found the fault. The fault is a corrosion failure of the connection. You know what? I could have, if I had to guess, I would have guessed exactly this. So now I'm going to take a little break and then we're going to look at how to fix this. We fix it, I get a big pat on the back. Okay, I've got the close-up camera staring right into the key spot, and the objective is find the loose wire. Find the loose wire. So we're looking at the good connection there right now. And let's just go hunting here. Let me turn this. Somewhere in here is a copper wire. So here's the what it was connected to. How's that going to help? Well, it's got to be right in this area here. So it's probably broken right off, right level with something. Does that make any sense what I just said? Okay, I see a wire here. Oops, not there. Wire here. Right there. But I really want to see like a copper end sticking out. The dust flying around. Some portion of that dust is asbestos particles. Not much of it though, because I'm not poking on the asbestos right now. Looks like snow. Snow. Yeah, I got up this morning and winter has returned. Ground is white with a thin layer of snow. And snow coming down, 0 degrees. What happened to the spring? Now they showed us spring there for a good couple weeks, but now they're showing us winter again. So I think the name of the game here is to pick away at this very carefully until all of a sudden a wire end shows up. I don't see any wire end in there yet. Let's look at the other wire. How does it run? Because it'll run very similar. So you see, it's in behind this layer here. I've peeled that layer off. Oh wait, is it? Maybe it's the same as this. There's some compound in here or some kind of black tarry material, and it's got shiny surfaces on it. Is that the wire right there? How do you even recognize it? Let me move this other wire out of the way here. I don't want to move it too much. I'm going to break the other wire. So there is something coming up right along here. It looks like it ends right here. Of course, if it's the wire, it'll be corroded on the end and it'll break easy. What did they do in here? Is that a wire? That really looks like a wire back there. It's all disappearing. You know what that is? I think that's the edge of where some tape ran and some compound formed on the edge. Ooh, wait a minute. Did I just... No. How about getting a better tool here? Get a better tool. Here we are. This is better. Look at that. Oh, what's that little nip on the end there? Oh, for crying out loud. I must have bent that. Let me get rid of that little fish hook thing. How's that look? That's better. Okay, let's pick away here. There's a wire. I see a wire under there. Oh, there's all the wires. All kinds of wire under there. Doesn't look very good inside here. Pull this whole piece off here. This insulation's really not helping anything. It's just sitting here. It's, you know. Does that look overheated in there, or is that just the way it is? Where's the broken end? Never picked one of these apart before, like this. Never had to. Where's the wire? Oh, that really... So this wire is insulated with a very thin film of varnish, which is the go-to way to insulate wires. The varnish is slightly flexible, so it adheres tightly to the wire. The wire can be then, you know, reeled up on a reel, sold. Ooh, don't pull on that. We're reeled up on a reel, sold, and then unreeled, and then maybe made into this coil, and all that working of it, it's made to take. Okay, we must have enough off by now, eh? There's no end jumping out here. Where? Ooh, what's that? That's just a piece of fiber. Probably asbestos. Yeah, look at the fibers coming off. Now a lot of that is coming from this black tape, I think. And so it's not asbestos roaring out of there, but some of that must be asbestos. What's that spot right there? It's gone. Whatever it was just a piece of paper. Well, I'm not seeing the end of the wire. Not quite what I was expecting here. I'd be handier with this tool if I were looking straight at it, but I am looking on the TV camera. Well, this is where the wire was. If we push it back, you can see it was kind of right in here. So anything at all that looks a little wrong. Okay, the wrong thing disappeared there when it's just a flake. One of these wires coming across here is ending. It's broken off. It's got to be right in this area here. And okay, I'm going to maximize the, I'm going to arrange it so I can move the camera as close to the work as possible. And we'll see what we find here. Find that we can't see here. Let me just pull this away. There. Okay. I think we got the camera a little too low. Spot the wire. Now the funny thing is, you're looking at the same thing I'm looking at. You might have spotted the end of the wire, or you may have spotted something you think is the end of the wire, and you want me to poke at it, but I can't hear you. We're right on the spot. So, you know, if the wire had been peeled away from further back, and broke off at the connection, there would be a bunch hanging out, just like over here. There's a bunch hanging out. There's a bunch hanging out somewhere down in there. The two wires might have come out kind of together and then be split to go to the different wires. So where this one comes out, the other one may have come out of the winding. Okay, so there's the one. There you see another one. But there would be a bunch of wire hanging out. Like it would hang out all the way over to here where it broke. And I'd see it. Oh, I don't see it. And also, its color is going to be slightly different. Also, it's not going to be smooth and straight. It's going to be kinked up like that other wire, because whoever worked on it would have bent it and twisted it. I don't see it anywhere. Camera's a little bit in the way here. Okay, hold on a second here. The focus up so close now. Let me change it again. wants to fall over for some reason. Oh, I know why I'm leaning on the wire. Pulling the camera wire here. There. Okay, I see something right, this one right here. It's pretty loose. So one alternative is to pick any wire, cut it, and hook up to it, and hope you've managed to hook up to most of the coil. So this wire appears to be coming out from down low. Would that mean the other one came out from up above? You got to imagine when they wind this, one end is on the surface and the other end is buried inside the coil. To get the inside wire out, it probably comes up and out the top edge or the bottom edge of the coil. So the back wire or the bottom wire can make it out to the connections. Oh my gosh. How much can you bend one of these wires? So if it came out and it came out on the bottom is still covered by all kinds of paper here. Let me get it out. Oh, that was a good chunk. Anything up here? Any wire? Again, there'd be a long length of wire hanging here to go from where I'm talking about all the way up to where the connection is, and that wire would be there, and I would have seen it already. It's not adding up very nicely, is it? This is so what they've done is they've laid at least one turn of tape. This one here, this one I'm poking on, over top of the windings, and then brought up the lead over top of that sort of first layer. That first layer, no doubt, is this layer over here. So the wire would have been brought up over top of this layer. And where are you? I can't believe I've got this far and I cannot find the end of the wire. That's a little surprising here. I mean, where would it go? It can't really go anywhere. Let me yank that stuff out of there. Yeah, yank. Don't yank anything. Yeah, I'm yanking that. For all I know, I'm grabbing the wire here and I don't even know it, so I gotta be a little careful. Just go out of the way. Oh, you darn paper. So why did they use paper so much for insulation? Even the high voltage power cables I worked with when I was working, these things carried 8,000 volts to ground in these power cables, and the insulation was paper. I couldn't believe it when I was told that at first. I just refused to believe. What? Paper? I'd never seen paper as insulation. I'd always seen plastic because I'm a 60s, 70s kid. I see something. Oh, what am I seeing? Okay, let's try hooking it. You know what I'm seeing? I'm seeing I think I'm seeing the connected lead wire tugging away, and I'm pulling on that. Don't pull on that anymore. Okay, think about it again. Whoever did this is going to do something fairly similar. Look, see the way this is even? Oh, you can't even see it. Get this paper out of here. I kind of mucked up the connection there. Look at how green it is. Now you can really see the green in it. Look at that. So somehow this guy got moisture and the corrosion cut the thin lead wire coming from the coil, and this is not unusual. This exact kind of failure is not unusual generally. Look, there's very loose wire here. Oh, my phone just dinged. My high-tech watch here. I don't know what my high-tech watch is. Time to stand. Stand up and move a little for 1 minute. What do you think I've been doing here? I'm standing the whole morning. It's one of the benefits of doing this shop work is that I stand all morning. I stand here for a couple hours. That's great health. Great for your health. Just standing. We sit around too much. I'm not getting anywhere here so far. Where is that wire? So you can guess how many turns of wire there are in this coil. 50,000 million. So what if I just pick one of these outside wires? And just say, okay, that'll be the start from now on, and abandon some number of outside turns here. That would be great, but how do I know that's what I'm doing? I could just be energizing a little bit of the coil back to this wire. I think I'm looking for the rear wire, and this wire here, I'm guessing is a front wire, but it's just a guess. I could change that from a guess. I could dig down and find out if this wire is the rear wire in the coil or the inside wire. Let's call it the inside wire. And then I'd know enough to look for an outside wire. And that could come off anywhere in here. But again, why is this one so loose? But again, if this were the hookup wire, it would come out here. We would see it. It wouldn't continue around the bend. So I have examined coils like this long enough to actually find one of these turns coming along and just stopping, because it's broken off right at the surface of the coil. And I've never done it with a coil this big, but that is very involved. Observation take a long time, magnifier, all that stuff. But I'm not finding it. I'm just not finding it. I'm not spotting it. And I also know that basic rule, the longer you look, the more you see, and the more likely you are to find what you're after. Come on. This is so hard to do. This is why I think when I see doctors and they're doing surgery using cameras and stuff, oh my gosh, it was just a fiber. Wasn't big enough to be a wire. Okay, wow, I could do this for hours. Probably have to. I think I'm going to stop for a bit because I've been doing this now for 20 minutes. Need a little break. Maybe think of a new approach. What could that possibly be? What could you possibly do to reveal the end of that wire? I don't know. Okay, with that, I'm going to go drink some coffee. Okay, often I find it's good to stop and think for a while and kind of imagine where you're going with the work you're doing. Let's look at a close look again. I think I have a couple of approaches here at this point. Continue to look for the wire. I shouldn't give up on that just quite yet. It could be hidden under that stuff down low to the right there. Could come out the top, so maybe it's hidden up around the top part there. Again, I think there should be a chunk of wire hanging somewhere. I should be able to find it. But let's suppose I can't. I cannot find the other end. And the other end, let's also suppose, has come from the inside of the coil. I think we're done. I think we're done at that point. Now, if on the other hand, the wire we can see, the connection that's still intact, this one here, if that is actually from the inside of the coil, And I could pick off just about any of these outside wires here and attach the other lead wire, you know, the broken one here, to it, and we'd be back in business again. So look for the wire coming out from inside. See if the wire we can see is really coming from inside or just on the surface here, surface of it. Let's start with that. You know, this is the first time I've done anything like this, so I'm being very, very careful and cautious. Trying anyway. Let's split this apart here. You can imagine that the other wire is a little weakened too. I don't see any corrosion on it, but you can imagine it's weak at the connection, and it's going to break while I'm doing this. As long as the lead wire is available, I can always fix that. But I'd rather not break it. It's really taped. I think you can see the bottom corner of the tape. Oops. Just right in here. So I'm thinking that wire probably like this is one tape coming down and ending just here, and the wire probably just dips under that and goes into the coil. Can't we see it from over yonder here? You can see where it goes into the coil. This is the idea here. Ooh, 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 don't pick the wire. Yeah, like I was saying, those doctors who use wait a minute. I don't see it. Is it coming from way around? I really thought we'd see it when I pulled this paper back. Well, it must be running way up around the coil somewhere. Where we can't see it. Probably made this coil not in this housing here. They would have made it and then it slid it over. This is the center core of the coil. They would have slid it over that and then made all this here. Oops. Yeah, there's no way we're separating that. Taking the coil out, I can't imagine you can do that. Oh, this is one solid piece of metal that's been bent around. And look at how heavy it is too, because it's part of the magnetic circuit. So this is probably a fairly soft iron here. You can see the coil is built on a spool, and so if we could slide it out, but we can't. That's not an option. Not getting anywhere here at all. Now, do I need to know for sure that this wire is coming from the surface or from the back? Yeah. So what? Really, so what? If I can't find the other end of the wire, that's the big deal. Plus, if this wire is heading back this way, this way, the other wire must have been coming out the other way. Of course, we wouldn't know that if it's come from inside and it's popping out the bottom. Look here. So I'm trying to... Oh my gosh. Looking behind there. See any loose wire? Now the wire on this side is between these two tapes. Could it be the wire is still on this side but broken? between the two tapes. And if I looked for it, I'd find it. Right in behind these two tapes here. What two tapes? I'm gonna have to smash this up to find it. Piles of dust flying around. Not going well. Anybody see a wire jumping out there? I think we're approaching the this isn't going to work situation, and we're going to be moving into, oh, there it is. Right on the verge of giving up. That's got to be it right there. Coming out the top. Where's it going? There it is. Oh, fantastic. And you can even see it looks like a little bit of green on it. Fantastic. We're in business. All I got to do is solder that back up to the other wire. This guy's going to work again. Oh boy. Okay, feeling good. Going to stop for a while. Well, enjoy the good feeling. Get another cup of coffee. I think I might be succeeding here. Fantastic. Oh, I had to cut my coffee break short because I'm excited about this. And that's not good. Don't want to be too excited while you're doing this stuff. First step is to try to clean this and get it soldered back on. Second step is soldered back onto this lead wire, which is also terribly corroded. Doesn't have to look neat. Doesn't have to be taped up. It can all be left hanging open just like this. I just have to make these connections. So I'm going to get a little sandpaper here. I'm actually a little shaky. Well, it's good. It's shaky on the sandpaper. That's good. Now, last thing I want to do is break this. The most likely place for this little piece of wire, you can't even see it. It's on my finger there to break. The most likely place is right up on the coil. Right where, you know, right in the... Right there. If it breaks there, it's... well, let's just say the headache will go from being bad to enormous. Now, is this the right thing to do? Not really. I don't want to tug on it. But how are you going to abrade it? Don't need a lot of abrasion. Of course, I got my damp finger on it, and that's not going to... Well, when I heat it up with a soldering iron, if there's any moisture left, I'm just lightly abrading it here. I'm going to take a look with my magnifier. Where's my powerful magnifier? It's right here. Just take a look. You can examine the back of my head while I'm doing this. Well, that's probably okay. So now the other wire. The other wire is here. All this. The corrosion probably goes up into the wire a fair bit, and probably better off trying to clean this than cutting it back. I think that's it. I don't know what that is. Very, very small strand. Probably just one strand of this stuff. Okay, only get so far with your fingernail. So this connection has to be good enough to carry some current. There's going to be, I don't know, off the top of my head, 20 milliamps going through here. This also has high voltage on it. This has the power supply voltage on it relative to ground, relative to the chassis. So I have to just give a little thought to that while we're doing this. Great thing about this is, other than having to solder some wires back together here, I got this whole cord still intact. So if this works, I just plug it back in. I'm doing this and looking for copper color to show up, which I can see. Okay, I think I've done that enough. Now, what we're going to want to do is wrap this around it fairly tightly, and then solder it, and then we're done. And I don't want this tugging on it. Oh, don't move the other one, Jim. You're going to break the other wire before you know it. Don't have broken it already. No. Don't do that. This is just too much stuff here. Too much stuff. Now, how do you take this tiny little wire? You know what I mean? I don't really want this springing out. There's almost no spring pressure here, really. Push this down. Getting it in the right area. I think we're good. Gotta go around at least once, I think. The rest of it could just be a lap down the wire, but holy smokes. I can barely see what I'm doing. Stay there like that. Oh, that looks good. Okay. If anything's going to do it, that's going to do it. Here, let's take a look in the I'll give you a close-up view here. I'm not sure you can see too much with this camera, but kind of see how I've got it wrapped around. The wire still looks very green in the camera here. It looked a little better in the... All I need is just a few bits that are clear copper, and the soldering's going to work. Okay, let's do that. Let's solder this guy up. Hey, you know what? Before I do that, I can already check the... yeah, my meter is hooked up to this coil. Let's see. Show me a 0. That's not a 0, that's an open circuit. Oh, there we go. Oh, you didn't see it. 1.5 ohms. Perfect. This is going to work. This is going to work. While I'm soldering it, we'll keep the meter on. And if I'm trying to get the reflection off the face of it there. There we go. Come on, baby. Doesn't like the solder very much. A lot of smoke. I don't know, a lot of solder on the soldering iron, not much on the wire. That's better. See, we got 1.5 ohms. Sounds about right. Let me look with my magnifier here. Well, I think it's good. Can that take milliamps? Yes. It's out in the open, it's not covered, it can't heat up, it's not, yeah, milliamps is not that big a deal. Wouldn't want to put an amp through that, but okay. We're ready to actually test the radio. Just about. Let's So I'm going to get things set up to see if this really worked. Wow. So I've repaired this connection because I'm very hopeful that all this is going to go well, and really there's no reason to keep this open anymore. I opened the wires here to do a test, and we don't need them open anymore. So hopefully the speaker's going to work and it's going to go. It's going to go. It's going to work and go. Very good. Good enough. Okay. Next thing is to test the, we're back to testing the radio. Fantastic. While I was straightening up here, I knocked something down on the floor, and I'm going to show it to you. This is what I knocked onto the floor. It says the Terry Fox Run. Terry Fox is one of my biggest heroes in my life. Terry Fox was a little younger than me. He was living on the east coast of Canada. This would be in the 1970s, I'm pretty sure. And he got cancer in one of his legs. He had to have a leg amputated. So he's like 18, 19, something like that. Had a leg amputated. And what he decided to do was to run across Canada on one leg. That just sounds crazy. Running across Canada on 4 legs would be hard enough. But one leg. He started out on the east coast. I'm sure locally it was known, but nationally it wasn't known what he was doing. But as he proceeded along, basically hopping down the road. It's really, really kind of how it worked. He got more and more popular, and when he got to Toronto, all of Canada, certainly as he came into Ontario, all of Canada found out what this guy was doing. And he was on one leg, hopping along. And so after he left Toronto, he headed up north on a highway that goes up to a city called Sudbury. My wife and I happened to be driving that highway on the way to where my wife grew up, in a little town called Espanola, which is a little ways from Sudbury. And as we're driving up the highway, I see a camper kind of moving slowly on the side of the road. And then as I get close enough, I can see past the camper, and there he is. There's Terry Fox, all alone. He's 100 meters ahead of this camper, all alone, running on one leg. He had a very characteristic way of running. It's not apparent in this photo. I took a photograph of him. I have a photograph of him running on the side of this highway outside of Sudbury. So he made it all the way to a place called Sault Ste. Marie or somewhere like that. I'm not too sure. He made it around close to Lake Superior. And he started getting sick again, and he was diagnosed with cancer again. And he had to stop his run, and shortly after that he passed away. And I just think, now I've almost got tears in my eyes thinking about this. Look what that guy did with his life. Now, you know, all over the world there are Terry Fox runs now. People run to raise money for various, beneficial things. All because of this man who I saw with my own eyes. Running all alone. I mean, it's a lonely place up in northern Ontario. Yeah. Okay. Now I'm all upset. I'm upset in a good way. Upset in a good way. Okay. I'm surprised how emotional I got there. Yeah. Now, if I find that photograph, I'll have to show it on a future video. It's a classic photograph of Terry Fox running. Okay, we're going to try this guy out now. Just, let's see if we're going to plug him in. Everything is safe and ready to go. Ground wires hanging here, antennas hanging here. Oh, we got to put an antenna on it. You know what? We need an antenna because we're going to want to listen to a station through that speaker for some reason. Reassurance. So I'm going to stop for a bit and calm myself down. Yeah, I got upset. I rummaged around a bit to try to find the photo of Terry Fox. I couldn't find it, but I found a bunch of other photos. Come down memory lane with me back when I was working. This would be in 1980, 82, something like that. And you get a look at me at work. So that's me. And that's one of my crew trucks there. And that's a couple of my guys. And they're going in a manhole. And this is downtown Toronto, somewhere I can't recognize where. If you were there today, it probably looks different now. Cones out to try to direct the traffic. This is me experimenting with a 3D camera. I bought the film camera, I bought a 3D camera, and the idea was I was going to take three-dimensional pictures in manholes so you could see the layout of the cables better, because it's a bit of a spaghetti jungle inside a manhole. Yeah, both of those are me. Well, let's save that one for the end. This is me. That's me there. You can tell from the lack of hair. And that's a manhole lid on the floor. This is a safety meeting, and I'm discussing the safe way to open a manhole. I'm demonstrating it with a manhole lid. You know, I think it weighs 300 pounds. It was a heck of a thing to get into this room and that. But there's a technique to reduce the strain on you when you're lifting the manhole lid out, and some risks in that. And we're just discussing it there in a safety meeting. Okay. Before I was a supervisor, when I was a union employee, we went on strike. That's me on strike with another employee here, standing around a barrel of burning stuff in the winter, trying to keep warm at the picket line. This is me in my office at Toronto Hydro. I was lucky. I had a pretty big workspace. I had a large area to roll out drawings to study here, because we were building manholes and conduit and stuff. We had big long drawings showing that kind of stuff. That's all my corrosion certificates there. Yeah, I got that much behind me. That's why I knew a little bit about the green stuff on the wire there. Yeah. And here's my last photo. Okay, this is me sitting here at my desk. This is my assistant. And he's not my boss, he's my assistant. And we're looking at some corrosion damaged materials on my desk. It's a bit of a setup photograph, frankly. These are ground rods that should have been 10 feet long, but look, the end of it is gone. It's corroded away. This is another, this is an eye bolt to hold back a pole, and the bottom of it has corroded away. And this is really hard to see. This is a large piece of copper cable here, wrapped in a cloth covering. Not much different than these wires in here, only look at the size of it. It's really, really big. This is a neutral, came out of the bottom of a manhole. And this is interesting. I was in this manhole. It's 2 feet of water. I'm sloshing around in the water. I have boots on and whatnot. And down on the floor are the neutral cables, including this one. And they're all white. Well, not supposed to be white. This is actually a black cloth. How'd they get white? So I kicked one, and my boot went right through it. There was no metal in the wire. It was completely corroded. I pulled up this chunk to bring it back to the office to show around. Pulled this chunk up, and it was white. I put it in my truck, and I noticed already it was no longer white. It had become a little bit green. And when I got it to the office, it wasn't white, it was green. Just in the matter of, 20 minutes, it had turned from being a white material to green. And that's a chemical action taking place because of gases in the air. I don't know exactly what was going on, but it went from white to green in there. That's a corrosion thing. That's a little picture of my wife there. Okay, enough memorabilia. Back in the day, I do have corrosion credentials, but mostly related to a corrosion underground of structures like piping, and in my particular case, cables. Well, it's a cable going to corrode? How can it corrode? Because the outside of a cable is a lead pipe. On these old cables, it's just a lead pipe on the outside. A lead sheath is what it was called. And that corrodes. And then water goes in and the cable goes boom, the lights go out, and I jump into action. Okay, I've delayed this long enough. I'm trying to allow times, for something to come up. There's nothing coming up. There's nothing that was going to come up. We're going to start with it off. Yeah, oh, no antenna connected. I turned it on but did not connect it. Let's connect an antenna here. It's an outdoor antenna. Okay, ground to ground. Antenna to antenna. Okay, one early indication that this is working will be a lower voltage on this capacitor. Last time we measured a big voltage there. I'll get ready to measure that voltage again. If the speaker doesn't work, then we're going to want to know that voltage right away. So let's get ready for it. So it's 450 volts here, open circuit, because of the open circuit there. hopefully the circuit's closed. The 450 won't be there. Or if it is there, it's only there very briefly. Let me ground this. Okay, because stuff might happen. I don't know what's going to happen. I don't think anything's going to happen, but that's when you get into trouble. Nobody told me that would happen. .600 volt DC setting. Check in here. There we go. Okay, switch is off. Everything's normal. Good. Power off. Switch on. Volume up just a wee bit. Come on, man. Work for me. I don't see 450. Other capacitor. We have done it. This was a 0 last time. All we need to do now is hear something. Quickly. Wonderful.
What Tesla is going to do, cut prices further, because if he does cut prices further, that is going to affect the cash flow at Tesla.
Yeah, it's a kind of a vicious cycle there. And I remember Kevin Tyne, the auto analyst of Bloomberg Intelligence, he said to me years ago at the beginning of the day, at some point, these electric vehicle companies have to start bending metal. And that's a tough thing to do at scale. I think we're finding that out for some of them here. And again, part of the issue, if not the biggest part of the issue, is what is the ultimate demand for EVs out there?
Yeah, what is the ultimate demand? You know what the thing about a lot of things in the world now, including electric vehicles, is everything is changing so quickly and so rapidly. And it's so complex. There's so many places, so many people, so many companies, so many things happening. Nobody can predict the future of what's going to happen next. And that probably has been the truth all along, except there are periods of time where we feel very comfortable that we can predict the future, and so we feel more comfortable. But right now we feel we can't predict the future. We probably never could. Very good. Unless you watch Tony Seba. Have you heard that name? Tony Seba. S-E-B-A. Look for videos by Tony Seba as he uses very strict mathematical approaches to anticipating what's going to happen, especially in the automotive industry. He's saying next year, 2025, we will see $5,000 electric vehicles available in North America. $5,000? What? And he's never wrong. Okay, I'm going to end it here. This is a good spot to end it. So thanks a lot for watching, and tomorrow we'll get back to doing the Bluetooth thing here. Wow, happy day here. Whew. Dodged a bullet. See ya.